Hi folks, welcome to Algebra 2 Common Core. Today we're going to review fractional exponents from a previous lesson. So recall that when I have an exponent of 1 over n, so any base raised to the 1 over n can be rewritten as the nth root of b to the first power. I don't have to put that first power in, so it's just the nth root of b. Now, if I've got an exponent that has a number other than 1 in the numerator, b to the m over n, I can write that as the nth root of b to the m, or equivalently, the nth root of b raised to the m power. So it doesn't matter whether I evaluate the root first or the power first. So back in our exponent unit, remember that we did all kinds of evaluating when we had numbers raised to fractional exponents, and we got very good at doing those sprints. So we want to recall all of those evaluations from previously. In this unit, we're mostly going to be dealing with variables raised to fractional exponents. So in example number 1, the square root of x to the 7th. When I see a square root, remember that it's understood that the root number is 2. So this would be rewritten as a fractional exponent, x to the 7 over 2. When I see the fourth root of x to the 6th, that'll be x to the 6 fourths. But of course, that fractional exponent can be reduced, so that would be x to the 3 halves. Again, I've got a square root of x raised to the 6th power. So this would be x to the 6 over 2. And of course, that would be reduced to x to the 3rd power. And lastly, the cube root of x to the 10th would be x to the 10 thirds. So again, get used to that notation again. In example number 2, we're going to evaluate. I've got a function, f of x is equal to 10x to the 3 halves minus 24x to the minus 1. And we would like to evaluate f of 4. Now it says please do this without a calculator and show the steps in your calculation. So for this example, we want to do f of 4. So let's substitute 4 in for x. So I've got 10 times 4 to the 3 halves power minus 24 times 4 to the negative 1 power. Now let's deal with the fractional exponent first. So this will be 10 times the square root of 4 to the 3rd. So think about that as you're writing that down. I'm going to keep going with that part of my expression. So 10 times, do the square root of 4, which is 2. 2 to the 3rd is 8. So we're going to multiply 10 times 8. In the second part of the expression, I've got a negative exponent on just the 4, so that means that that portion I have to take the reciprocal of. So this would be minus 24 over 4 to the first power. 24 divided by 4 gives me 6, so I've got 10 times 8 minus 6, so 80 minus 6, giving me my final answer, choice number 4, 74. In example number 3, we want to know which of the following is not equivalent to x to the negative 7 thirds. So I'm going to think of a few ways to rewrite x to the negative 7 thirds. First of all, let's get rid of that negative exponent. So this would be the same as 1 over x to the 7 thirds. Let's see, is that one there? Yes, it is. So choice number 1 is equivalent. I could also write this as 1 over the cube root of x to the 7th. Let's see if we see that one. Yes, of course, choice number 3. So that one is also equivalent. And another way of writing this would be what we see in choice number 4, the cube root of 1 over x to the 7th, only because the cube root of 1 is also 1. So this one is equivalent as well. Clearly, choice 2 is not equivalent because in exponential form, this one would be x to the negative 3/7, which is not equivalent to the given expression. Now in our next few examples, what we'd like to do is review simplifying radicals from Algebra 1. So when I see something like a number 28 underneath a square root sign, there are two different ways that I can approach this. I can say 28 is not a perfect square, but it does have a perfect square factor. The perfect square factor would be 4. 4 times 7 is 28. So the square root of 28 would be equivalent to the square root of 4 times the square root of 7. Square root of 4, of course, is 2, so my final answer, 2 radical 7. So in that method, I'm looking for the biggest perfect square factor of the radicand. In the other way, in the other method for simplifying the square root of 28, I like to think of my factor trees. Everybody's good at factor trees. So 28 could be written as 2 times 14. But then 14 is 2 times 7. If I want to find a square root, that means I've got to find two identical factors. So I can factor the 2 out because that came from a perfect square. What's left underneath the radical sign is the 7 because that was not part of a pair. Let's take a look at the square root of 300. I'm going to alternate between my two methods. So for the square root of 300, let's think of this as the square root of 3 times 100, because of course 100 is a perfect square. The square root of 100 is 10. 3 is not a perfect square, so the 3 stays underneath the radical. So in simplified form, the square root of 300 is 10 radical 3. When I get to an example like 72x cubed, I'm going to simplify this by doing my factor tree. And again, you can pick a method and decide which method you like to use. So 72, I could write that as, how about 4 times 18? 4, of course, is 2 times 2. 18 is 2 times 9. And 9 breaks down into 3 times 3. I also have an x cubed, so I can expand this as the prime factors 2 times 2 times 2 times 3 times 3, and then 3 factors of x. Since I need a perfect square, I need 2 factors that match. So here's 2 2's, here's 2 3's, and here's 2 x's. All of the factors that are doubles come out just once. So 2 times 3 is 6 times x, and then left underneath the radical would be 2x. And again, you could also do this one by looking for a perfect square factor that goes into 72x to the third. For the last one, 2 radical 75a to the fifth. I know that 75 is 3 times 25, and I know that a to the fifth is a times a to the fourth. So I've got a 2 on the outside. I can take the square root of this product, 3 times 25 times a to the fourth times a. So 25 is a perfect square, so take the square root and get 5. A to the fourth is a perfect square, that gives me a squared. What's left underneath the radical? The 3 and the a. So on the outside, remember to multiply by the 2 that came to us in the original problem here. So 2 times 5 is 10a squared times the square root of 3a. Please pause the video and take a few minutes to simplify exercise number 5, all 3 examples, and then come back and check your answers with mine. Here are all of the correct answers, but when I check your notes, I expect to see the work that you did in order to get those correct answers. So please don't just write down the answers. Make sure you're showing the work to get those answers. Now, we can use a similar method when we're simplifying with higher order roots. So that means bigger than square roots. So for example, if I've got the cube root of 16, some of you recognize that 16 has a perfect cube factor. 8 is a perfect cube. And then we're going to say 16 is 8 times 2. Well, the cube root of 8 is 2, but that would then leave me with the cube root of 2 still underneath the cube root sign. For this, make sure in your final answer you include that cube on your cube root. Now, if you don't recognize a number as having a perfect cube root, we can still factor it using your factor tree. So 108, I know that that breaks down into 2 times 54. Keep breaking it down, so 54 is 6 times 9, 6 is 2 times 3, 9 is 3 times 3. Now, this time, since I want a perfect cube, I'm looking for 3 factors that match. So I've got a triplet of 3's. So I'm going to say bring the 3 out, and underneath the cube root sign, I still have left this 2 and this 2. Multiply those together, so that gives me a 4. If I look at the cube root of 250, we can probably remember that that's 2 times 125. 125 is a perfect cube, so I'm going to say take the cube root of 125, which is 5, and you're left with the cube root of 2. For the next one, 128, that breaks down into 64 times 3. X to the 8th, I need a perfect cube, so that would be x to the 6th times x squared. When I take the cube root of each of those numbers, 64 times 3 times x to the 6th times x squared, the cube root of 64 is 4. The cube root of x to the 6th, well, let's see here, how many triplets do I have? I have 2 triplets, so that would be an x squared coming out. What's left underneath the root sign? The 3 and the x squared. Notice that neither of them have any perfect cube factors. For the next examples, we're looking at even higher roots. The 4th root. So 162, I know that that's 2 times 81. Do you recognize that 81 is a 4th power? So this is going to be 81 would be 3 to the 4th. So the 4th root of 81 would be 3. And I'm left with the 4th root of 2 underneath the radical sign. Now again, if you don't recognize it, go ahead and do your factor tree. So 4 times 4 gives me 16. 4 is 2 times 2. 4 is 2 times 2. But then I've got 8 factors of x. So in expanded form, this would be 2 times 2 times 2 times 2, and x multiplied together 8 times. I know this seems tedious, but until you get the pattern here, you may want to go ahead and multiply them all out. Since I'm looking at a 4th root, that means I want 4 of a kind. So there's 4 2's. Here's 4 x's. Here's another 4 x's. It looks like everything is coming out of that root sign, so I'll have a 2 and a factor of x and another factor of x, giving me my final answer of 2x squared. For 48x to the 10th, y to the 5th, we know that 16 is a factor of 48, 3 times 16. And we just saw a minute ago that 16 was a perfect 4th. So 2 to the 4th is 16. So I'm going to be able to take that 2 out and leave the 4th root of 3 underneath. X to the 10th, how many groups of 4 x's are there? There are 2 groups, so I'm going to write that as an x squared. I'll still have 2 x's left under the radical, so I'll write that as x squared. Y to the 5th has 1 group of 4 factors of y with 1 extra y left underneath the radical sign. So 2x squared y times the 4th root of 3x squared y. For our last example, we're looking for a 5th root. So 2 to the 5th power is 32. So 32 times 2 would give me 64. When I take the fifth root of 32, that gives me 2. The fifth root of x to the 12th, I just need to ask myself, how many groups of 5 x's do I have? I have 2 groups of 5 x's, but there's still 2 factors of x left without partners. Y to the 15th would have 3 groups of 5 y's. So underneath the fifth root sign, I still have that extra 3 as well as the x squared. So it's going to take some practice to get good at these radicals. For this last example in this lesson, we're going to review our exponent rules. So in part A, we see that we've got x to the 5/3 times x to the 3/2. When we're multiplying, we need to add exponents together. So this is going to be x to the 5/3 plus 3/2. Now yes, you could go to your calculator and do that sum, but I'm going to do it with a common denominator here. Common denominator is 6, so that gives me 10/6 plus 9/6, giving me an answer of x to the 19/6. As a root, we would write that as the 6th root of x to the 19th. Now to simplify that, there would be 3 groups of 6 factors of x. So we're going to take out an x cubed, but that would still leave us 1 factor of x underneath my 6th root sign. So remember that the question says simplify it in simplest form as an exponent and also as a radical. For the division problem next to it, we know that when we divide, we subtract exponents. So 5/2 minus 4/3. Go ahead and find your common denominator. I think it's 6 again. So 15/6 minus 8/6. So that's giving us x to the 7/6. So that's in simplified form as an exponential. As a radical, this would be equivalent to the 6th root of x to the 7th. But again, we can take out 1 group of 6 factors of x and still have 1 factor of x left underneath the radical. So that would be my simplified radical expression. For part C, a negative exponent just means that I'm rewriting this as the reciprocal. So move the x to the 3/2 to the numerator and make its exponent positive. This would be the same as the square root of x to the 3rd, but that's just the square root of x times x times x. So I can take out 2 factors of x, write it as x radical x in simplified radical form. Let's go to part D. Division, x to the 3rd divided by x to the, this would be 1/2 as an exponential. Subtract your exponents, so x to the 3 minus 1/2. 3 is the same as 6/2 minus 1/2. So in exponential form, this would be x to the 5/2. Write this as a radical square root of x to the 5th. Simplify it, square root of x times x times x times x times x. There are 2 pairs of x's, and I'm looking for pairs because I've got a square root. So x squared comes out, leaving me with radical x underneath the radical sign. Now we haven't talked about the power rule again. When I'm raising a power to a power, I multiply the exponents. So 8 will be raised to the 2/3. X will be raised to the 5 times 2/3. 8 to the 2/3 means let's do the cube root of 8, 2. 2 squared gives me 4. X to the 5 times 2/3 would be x to the 10/3. To simplify this in radical form, that would be 4 cube root of x to the 10th. Now hopefully at this point you're not going to want to write out 10 factors of x and look to see how many triplets you have. you should have 3 triplets. So that would be 4x to the third. And then there'd be 1 left over that wasn't part of a triplet. So we're going to write that as the cube root of x. Let's see, for the last one, let's do our exponential first. So 27 to the 1/3, x to the 1/3, divided by 6, x to the 1/2. 27 to the 1/3 means take the cube root of 27, so that's 3. X to the 1/3 over 6x to the 1/2. 3 divided by 6 gives me 1/2. Never write this as a decimal, always as a fraction. X to the 1/3 minus 1/2. When I do that subtraction, it'd be 1/2 x to the 2/6 minus 3/6, which is negative 1/6. Negative exponent means move it to the denominator, so 1 over 2 x to the 1/6. As a root, 1 over 2, the 6th root of x. Now take a few minutes to please jot these examples down in your notes under the You Try It's, and please do the problem showing all of your work, and then come back and check your answers with mine. Okay, checking your final answers on example number 1, you should have had 12x to the 5/6 as an exponential. 12 times the 6th root of x to the 5th, which can't be simplified because there's fewer factors of x underneath the radical than we have for our root number. For number 2, I simplified that down and got 1 over 2 x to the 1/4 as a radical 1 over 2 times the 4th root of x. For number 3, I broke 56 down into 8 times 7. 8's a perfect cube, so the cube root of 8 is 2. 7 is not, so it stays under the cube root sign. X to the 4th has 1 triplet, so I took out x and left the extra x still underneath the cube root sign. Y to the 7th would have 2 triplets, so y squared comes out, and that left 1 extra y underneath the cube root sign. So in simplified form, 2xy squared times the cube root of 7xy. So we've done a lot of practicing with exponentials and roots. This should all be review, but we want to make sure that we understand simplifying radicals before moving on to the next sections of this unit. We'll do lots more practicing in class. Have a great night.